Okay students, let us have a look about what is magnetic field and what is the force experienced when a charged particle is moving in a magnetic field. Right, to start with magnetic field. Field means we know that this is a space around anything in which its interactive force can be experienced. We have studied in our first unit about the electric field, which is the force experienced by electric charge when it is kept in the vicinity of any source charge. So accordingly, magnetic field is the space around a current carrying conductor, right? It is a space around a current carrying conductor in which its magnetic effect can be felt, right? Just like I have explained in my previous video, that when we keep a magnetic needle along with the current carrying conductor, it gets deflected. So why it have been deflected? It have been deflected only because there was another magnetic field related to that, due to which interaction would have taken place, right? So this is the space around a current carrying wire. So this is a wire, so this would be the space around the wire in which if we keep another magnetic needle which would experience a deflection, so that space is known as the magnetic field. That space can be around any magnet also, because we know that when we are having a magnet and we keep another magnet and we bring another magnet toward it or away it, we feel a force of repulsion and attraction accordingly which pole is near to which pole. For example, if we are having n pole and if we bring n pole of another magnet, it would be repelled, and if we bring s pole of the another magnet, it would be attracted. So why this attraction or why this repulsion have been taken place is just because of the space around that magnet, intervening magnet. So when we bring that another magnet toward it, so it basically disturbs the magnetic field of the presenting. This is the source charge, we can say source magnet, right? So we are bringing another magnet in the magnetic field of the source magnet, and that is why this interaction have been taken place. Now there is a word, that is magnetic flux density. Magnetic flux density, or we can say another word is magnetic induction. Important to note that both these words are associated with the strength of magnetic field. Means what? This magnetic flux density or this magnetic induction indicates what is the strength of magnetic field at that particular point. Just like we have studied in our electric field chapter, like I will compare so that you can understand the concept. Like for example, we are having a source charge, and when we bring another test charge near the vicinity of this charge, it will experience a force of repulsion or attraction depending upon what is the nature of the source charge, right? Because the test charge we always take to be positive. So when it is closer, the strength is more. When it is far apart, the strength is lesser. Similarly, this magnetic flux density and magnetic induction indicates the strength of magnetic field. Now I will more elaborate this definition, this word, magnetic flux density. Magnetic flux density, right? Now density, we actually know that is magnetic density. We know the formula, that is mass per unit volume, right? Here in this case, when we are dealing with the flux densities, we talk about how many magnetic field lines are passing through that particular area, right? So for example, we are having this area and we keep this magnet along with it. So how many magnetic lines of force, just like electric lines of force we have studied in our previous chapter, how many magnetic lines of force are passing through this area will give that magnetic flux density at that particular point, right? So I hope this is clear. Magnetic flux density is, magnetic flux means field lines. Number of field lines passing per unit area is known as magnetic flux density. Magnetic flux is measured in Weber, and magnetic flux density is measured in Weber per meter square, as this is flux per unit area, right? So similarly, if we talk about the magnetic induction means it gives you the strength of magnetic field at particular time, means how much force is experienced by that particular magnet or test magnet, we can say, at that particular point is gives you the name, which is magnetic induction, which also indicates the strength of magnetic field at that particular point. Now let us have a look about what is the force associated with a charged particle when it is moving in a uniform magnetic field. This will be discussed in our next video.